Welcome to You'll Get That Nugget for GCSE Maths. Today we'll be concentrating on giving you a framework to answer questions about equations of straight lines. This session is to complement your lessons with your teachers and is not to replace them in any way. Okay, so this is the first of two sessions on equation of a line, and this first session is going to be a little bit of an introduction about the formula that we use to calculate the equation of a line, how we use it, what information we can take from that, and then some other sort of applying questions to do with that. And then there'll be another session on when you have got a straight line, how you then calculate the equation of the line. So first and foremost, the thing that we need to know about equation of a line is the general formula to calculate it. And that general formula is this: y equals mx plus c. Now, my suggestion is you make note of this, you need to learn this, and you need to learn how to use it. Now, on a graph, we've got our y coordinates and we've got our x coordinates, so that's what the y and the x there represent. And what you'll also notice is we've got two other letters. We've got m, and m here stands for our gradient. Now, if you're unsure on what a gradient is, there is another video on gradients completely and how we calculate them. But ultimately, our gradient is the steepness of our line, okay? And then what we've got here, C, is what represents our y-intercept. Now, our y-intercept ultimately is where that graph crosses our y-axis. So you've got your x and your y-axis, and the C is our y-intercept where we cross that y-axis. So let's have a look at example 1 then. Write down the gradient and y-intercept of the line y equals 3x plus 2. Now, it is not uncommon on a foundation paper for a question like this to come up where you simply just have to identify what the gradient is, or you simply have to identify what the y-intercept is. So you need to understand this, and you need to understand which values here represent each of those. So first and foremost, if we look at the gradient then, so the gradient is the steepness of the line, like I said earlier, and that is the number that is in front of our x. So if we look here, we've got 3x, so our gradient is going to be 3, okay? And that means we've got a steepness of the line of 3. So for every 1 square along we go on our graph, we go up by 3. Okay, then we've got our y-intercept. Now our y-intercept is this numerical value on the end, which is a 2. Now, our y-intercept, I tend to write it as a coordinate because it is a coordinate on the graph. And our y-intercept, our x value is always going to be 0 because we won't have gone along any. And then we are just looking at where it crosses the y-axis, which in this case is a 2. So it's going to be 0, 2. Okay, let's have a look at example number 2 then. So write down the gradient and y-intercept of the line y equals minus x minus 1. Now, you'll notice we don't have a number in front of the x here. However, we can still calculate the gradient. And the reason we can do that is because in algebra, when we have a letter by itself, ultimately what we're saying is we've got one of those letters. We just don't write the 1. So in this case, where we've got minus x, it means we've got minus 1 of those x's. And so our gradient is going to be minus 1. And then if we look at our y-intercept, we have got our value on the end, which is minus 1. So our coordinate is going to be 0 because we won't have gone along any. And our y-intercept, it will cross the y-axis at minus 1. So 0, minus 1. You'll notice that this was a plus 2, so this was a positive number here. This was a minus 1, so it was a negative number here. Okay, example number 3. Write the equation of a line that has a gradient of 5 and a y-intercept of minus 4. Now, this is ultimately just working backwards from example 1 and example 2. You have been given the gradient, you've been given the y-intercept, and you just need to write it as an equation. So we always start off with y equals because that's our general formula. And then our gradient is 5, so it's going to be 5x. And then my y-intercept is minus 4, so I'm just going to put minus 4 on the end. And that's our equation of our line. Example number 4, very similar. However, this time it gives us the y-intercept as a coordinate. Now, you'll know from up here, if our x-coordinate is 0, that means our y is the y-intercept point. So I can see here my y-intercept point is going to be 3. So for this equation, it's going to be y equals my gradient, which again is 5x, and passes through the point 0, 3. So my y-intercept is going to be plus 3, and it's going to be a plus because this is a positive number here. Okay. Now, the other thing you may get is when you are given a question that has got a coordinate and you have to identify whether that coordinate lies on that line. So if you imagine you have a graph, does this point here lie on that graph? And the way we do this is through using substitution. So does the point 2, 5 lie on the line y equals 2x plus 1? Now what we're going to do is we're going to look at this bit here, 2x plus 1, and we're going to look at our x coordinate here. Now our x coordinate is 2, our y coordinate is 5. And I'm going to substitute my x coordinate in here. So I'm going to say 2 brackets, okay, and my x coordinate is 2 plus 1. So all I've done here is I've replaced my x for my x value here, which is 2, okay? Now what I'm going to do, and this is y, so y equals this bit here, I'm just going to simplify that. So y equals 2 times by 2, which is 4, plus 1, so y equals 5. Okay, so what I've done here is I have said if my x value is 2, that is generating me a y value of 5. Then all I need to do is I need to go back to my original coordinate, which is 2, 5, and see what my y value is. Now my y value matches, which means that yes, this must lie on the line. Okay, let's have a look here. So does the point 3 minus 1 lie on the line y equals 3x minus 10? So let's say this is our x and this is our y. So we're going to say y equals, and we're going to substitute our x value in, 3 brackets, and our x value here is 3, take away 10. 3 times by 3, that gets us 9, take away 10. 9 take away 10 gets me minus 1. I then need to go back, I need to look at my y value. Is it minus 1? Yes, it is. So I can say yes. If I was to get a number here, say for example, I got minus 3 and my y value here is minus 1, my answer is simply going to be no, it doesn't lie on that line. Okay, example number 7, find the gradient and y-intercept of the line 2x plus y equals 8. Now you'll notice here, this looks slightly different to all of the equations we've looked at so far. And what this means is we need to rearrange this. Now, these are very common crossover questions, so you can find this on higher and foundation, but we need to rearrange this to have it in the form y equals mx plus c. So what that means is on my left-hand side, I need to keep a y, but on my right-hand side, I want my number of x's and my constant, my number on the end. So if I look at this example here, 2x plus y equals 8, my 2x is on the wrong side. I want it on the right-hand side. So the way I'm going to do that, if I write it down again, 2x plus y equals 8, is I'm going to subtract it. I'm going to subtract that 2x. Now if I subtract that 2x, that just leaves me with a y on this side, which is exactly what I want. However, because I've subtracted 2x from this side, I need to subtract 2x from this side, which is going to leave me with y equals minus 2x plus 8. Now what I can see is that this is in my form y equals mx plus c. And so from this point, I can then say my gradient, and my gradient is our value in front of the x, which in this case is minus 2, and my y-intercept is my number at the end, as a coordinate is going to be 0, 8. Okay, I've got one more example for you. So find the gradient and y-intercept of the line 4x plus 2y plus 8 equals 0. Again, we need this in the form y equals mx plus c to be able to accurately read off what our gradient and our y-intercept are. So we want to leave the y's on the right-hand side, but our x's and our on the left-hand side even. Our x's and our numbers we want to move over to the right-hand side. So the first thing I'm going to do is I'm going to subtract this 4x. That's going to leave me with 2y plus 8 on my left-hand side, because 4x take away 4x gets me 0. However, if I subtract that, I need to do the same from this side. So that's going to leave me with minus 4x on my right-hand side. 0 take away 4x leaves me with minus 4x. Remember, I want to just have y's on my left-hand side. So the next thing I'm going to do is I'm going to subtract 8. That's going to leave me with a 2y on my left-hand side, because 8 take away 8 gets me 0. But I also need to take away 8 from this side. That gets me minus 4x minus 8. Now, we also need it in the form y equals mx plus c, and you'll see that this is 2y. Now, in order to do this, what we're going to do is we're going to divide by 2. 2 divided by 2 would leave me with 1y, which is exactly what I want for in the form y equals mx plus c. However, because we do it to this side, we have to do it to this side. So I need to do minus 4x divided by 2. That's going to leave me with minus 2x. And I also have to do minus 8 divided by 2. And that's going to leave me with minus 4. What I can then do is I can save my gradient, because we have now got our equation in the form y equals mx plus c. My gradient is going to be minus 2, and my y-intercept is going to be my value at the end, which is minus 4. So as a coordinate, 0, minus 4. Okay, there's 4 questions for you to have a go at here. The first 3 you're finding the gradient in the y-intercepts. This one you need to do some rearranging like we did for example 7 and 8. And then this one here you've got a coordinate and you need to figure out whether it lies on this line.